Howdy, everybody. I'm here for day two. Before we get started with day two, though, I thought we'd go over day one. Obviously, Advent to code. Sorry, I didn't mention that. But here's where I made some changes a little bit. There wasn't a lot to change, but a little bit. Notably, there's an unzip method right here. So I was using collect. And apparently, if you just have two tuples that you want to unzip into two vectors, you can use the unzip button or unzip feature as opposed to collect. Um, so that was nice. I still don't really like the unwrap parse unwrap. There, I couldn't get it to work with unzip, but with collect you can actually turn results. How do I say this? With collect you can turn a vector of results into a result of a vector, like where it basically like where it the collect does the unwrap for you, and if it fails, and so you could replace all these unwraps with like questions marks like this. It actually looks like this, and then it would work. It still didn't look much nicer. I think if you really wanted to handle like error handling like this and were interested in it, you probably just use a parser library. Again, we're just doing puzzles, so it's not a big deal. But if you're doing this in real code, unwrap's probably not the way to do it. Look for something like nom or handle these errors via that collect and result kind of switching thing. Sort unstable. So if you look at the um, documentation for sort versus sort unstable. For these small ones, it probably doesn't make a difference, but sort unstable is technically faster, just because it just doesn't do um, it doesn't ensure that the order of the elements that are identical are maintained. And if that doesn't make sense, if you just think about like if you have like three ones in your array, and you've got a one here, a one here, and a one here. All the ones are going to go to the front, but the question is which one goes first? By default, the sort will make sure it's stable, so the first one will always go in the first position, and the second one will go in the second, and the third one will go in the third. Sort unstable is technically faster because it doesn't have to adhere to that. So I just changed that. I don't think I. Oh, I did use this counts. This was another thing we got from a viewer comment was you can use the iter tools, which I actually don't use a lot, just because I try to stick to the Rust standard library. But iter tools, excuse me, iter tools are actually really popular. They're used quite a bit, and it has a counts function. So as opposed to me building the hash map myself, I can just use this counts function. So you can go look in the gist and see I uploaded this, and you can like see the diff of the two stuff if you want to. Anyway, those are the changes I made for day one. Nothing big. I didn't change any algorithms, just simplified some code and stuff like that. So let's see. Can we go to day two now? I'll zoom this in a little bit, and we will go to day two. Return to the calendar. Day two. Red-nosed reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. I'll have to remember what year that was. I've done most of the years, not all of them, though. They're quick to add that since you're already here, they'd really appreciate your help analyzing some unusual data. You turn to check if the historians are waiting, but they seem to have already divided into groups and they're searching corners of the facility. Okay, so we're going to help with some unusual data. The unusual data consists of many reports. One report per line. Each report is a list of numbers called levels that are separated by spaces. For example, big block of numbers. 6 reports, 5 levels. So each report has 5 levels in this one. The engineers are trying to figure out which reports are safe. The red nose reactor safety system can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following are true. The levels are either all increasing or decreasing. Any two adjacent levels differ by at least one or at most three. Okay, so we're just going to check and find out which way we're going and make sure that no two numbers are more than 3 and at least 1 apart. This one is unsafe because it jumps here. This one is unsafe because it jumps too far here. This one increases then decreases. This is a dupe. That one's safe because they all increase by 1, 2, or 3. How many reports are safe? Okay, let's look at our puzzle input. This is just, I think this is just some array stuff, right? Is we're just going to manipulate arrays. Well, we aren't actually going to manipulate them. We're actually just going to review them. Doesn't look like we got anything crazy. Okay. Yeah, nothing big in the input. So let's make a input.txt file. And we should also just do the test code. Okay. I don't feel like there's anything crazy we can do here. We could use the Rust window. We've talked about like windows before. So like this, do you see how it can, you can like use this slice of windows to say like get 2 chunks of each, and then you just kind of like go through. We will have to turn it into a slice, which I don't think is too hard to do, but anyway, okay, let's get started. We'll just play with it as we go. So we want input equal include string input.txt, but we'll start with test.txt. And we're just going to parse numbers separated by spaces, right? So we'll say let, what are they called? Reports. Okay, so we parse, we do the lines, and for, it's actually going to be a vec of an I32. And then this one's going to be, we're going to get a line here. And in here, we want to like split the line by space and collect them. Yeah, just like that. So let's just print this. It shouldn't be really too big, right? So. Oh. I will get used to it. 76421. Yeah, there you go. Okay, not too bad. So now we have these reports in here. So we can just the solution then is for each report we count it if it's valid. So we can actually do, we can try and do some funky Yeah, we will do a filter and then we will do a count. I presume that's what it's doing. So we just got to fix this predicate. So we can actually change this to, and then we'll print line P1. So the question is what is this function right here that determines the validity of a report? And so we'll say first find if we are increasing or decreasing. So yeah, we'll say we're increasing, and if report, there you go. Decreasing like that. There you go. So the next thing I think we want to do, I can get rid of this over here, give us more room. Now we can do the windows. Okay, what is the AI trying to tell me to do? For window in Windows, if increasing in window is greater than that, else if not increasing in window is less than that. Okay, we can probably simplify that a little bit later, but that's the check increasing and make, and then we want to make sure difference is between 1 and 3. So we just do otherwise, what was that? Return true. Oh no, we continue and then we do true here. If difference or dispel. Okay, so what is it that we're doing is we're basically just saying, you know, we want to determine if we're increasing or not. And if we are increasing, we want one to be greater than the other or less than. Oh, do you know what? That actually solves the one problem here, right? Because if they're equal, it's neither increasing nor decreasing. So this one catches it. So we actually can just say, we can simplify this. We can say, oops, what's wrong with my, apparently some of the Vim commands aren't working. I just haven't set them up. Oh, I should mention too. Someone told me how to, in one of the comments, how to turn off the inlay hints. So that definitely helped. There we go. GQ. Did that do it? Three? Is that right? So the two. Boop. No. Okay, so let's think of which one would trigger. A mistake? Instead of a count, we can do collect. Do this and see which ones it found. Missing one. Is that it? Okay, so it's saying. Oh, I probably just need to do like a clone on it, right? Okay, so that one is correct. 76421 8. Okay, this one is not. 13609. So why would that not be? Was I wrong in supposing? I mean, like we could just do it up here. We could say like if report 0 equals report 1. Oh no. Oh, we have to do it in the windows, right? So we just check the first two and determine if 0 is greater than that one, then we're going down, right? So increasing is false. And then for each window, we can say, oh, I do think, yeah, I'm probably missing the logic here. So we can say if Windows 0 equals 0 equals Windows 1, return false. Else if, does that fix it? It does. Yeah, so for some reason I thought these, why wouldn't that be the case that it wouldn't catch the equals? Oh, if they're equal, this is not greater, so it marks it as increasing. So it would only check this one and it would say and one is greater than the other, but that's not the case. So it skips it. Okay, yeah. So my logic originally was bad, that this is off. Okay. So let's try the input and see if we get the right answer. Ooh, I don't want to. I want to do a count. No, right. 624. That's right. Okay, so just to recap, like what was happening here, right? We read our input, which are these reports, and we just do some data manipulation to turn them into lists of integers. And so then we're going to use this filter function, and the idea behind the filter is it's going to say, it says I'm only going to uh, or only return the ones that match the predicate is what it's called, and by predicate it just means this function right here. So whenever this returns true, I'm going to include that report, and then we just use a count. We say, hey, count all the ones that the filter matched. So this is pretty these are fairly common like functional programming things. Filter says, only include the ones that match the predicate, and then count says, as opposed to returning the matches, like if we did a collect, which I had before, we just want to count the ones that got through the filter, and so that gives us P1, right? So then the question is just what's in, how do we determine which of the reports should we pass through the filter? And so we just need to determine if we're increasing or decreasing. And then we can use this Windows feature. And again, I think I showed you, this is part of the standard library. If you have a slice, which we happen to have here, because the report is like a pointer to an array, which is actually a slice, we can call this Windows function, and it just returns like a window of the data. I think I've talked about this before in videos, right? So it'll do RU, then US, then ST. So we get like each of those chunks. And so then all we have to do with that is say, okay, well, just for each of those windows, are the criteria met? And this is like so this first one is check equality and increasing, decreasing, right? We want to make sure it's like going the same direction every time. So we already know it's supposed to go one direction. We want to say, is it going that direction? And so that's what those check. And then we do one final check that says, is the difference between our two items greater than 3? And if it's greater than 3, ooh, should I check? Might have gotten lucky. At most 3. Okay, so it has to be between 1 and 3 inclusive. So that is the correct one. I was wondering if I had to do an equal sign here, but I don't think I do. Anyway, so this says, hey, if the two numbers in this current window, these two values differ by more 3, then it's false. If we go through the whole list of windows, we've now iterated through all of the numbers, and we know that all of them are matched, and we can return true. And that's what we does here. So maybe I can just comment that right here. If we have gone through all the windows, it's valid. So that's part 1. Okay, let's see. Part 2. And again, this might... Right now, so far, these seem okay, but as they get harder, I may not be able to do these live solves. I have kids and chores and stuff that get in the way sometimes. Okay, part 2, though. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. Uh-oh. The problem dampener is a reactor-mounted module that lets the reactor's safety system tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now, the same rules apply before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. More of the above examples reports are now safe. So this one was always safe. Yeah, so like this one is still unsafe because like the idea is you're trying to remove one of these and you can't, like, you obviously 1 and 7, 8, 9 don't really help. You try and remove the 2 and you still have a 1 and a 7. And if you say, oh, maybe I try and remove the 7, but you still go 1, 2, then you jump to 8. So there's like too much of a gap here. Same with this one because if you get the 6 and the 2. So that is quite interesting, is like, I guess this doesn't apply to all of them, but the thing that was going through my head is potentially you can ask yourself the question, is the difference between these two numbers within this window sufficient enough that I remove this makes it okay? But that only applies to the gap of 3, not to the increasing, decreasing, which, yeah, is like shown right here, right? Like this one isn't safe, but it becomes safe if you remove the 3. Okay, so this begs the question, like, can I be intelligent about this? Or do I just, like, brute force it? Like, we've got 1,000 numbers and no more 1, 2, 3, 4, 5, 6, 7, 8. It looks like... So, if you figure we run the predicate test, but we run it iteratively by removing them, like at most you're doing 8,000 checks, I presume that's still like super fast. Does that make sense what I'm saying? Like sometimes I ramble, I realize. Like the question is like how do you determine which number you should remove? And there's a potential for you to try and make some rules and say, "Oh, if I'm increasing and then suddenly I decrease, if I know I should be increasing and then I decrease, should I do I need to how do I figure out which one to delete to get rid of it, right?" But then there's some logic here, right? Is my initial logic is this right here. I pick these two and say, "Oh, I must be increasing," but then I decrease right here. But the right answer is actually to remove this and then stay increasing, right? So there could be a case where that's switched around and these two numbers think you're decreasing, but you're actually increasing. So you have to, I guess what I'm saying is through all this mumbling is there's probably a lot of rules in corner cases. So do I want to do that or do I just brute force it and see how hard it is? I don't think it's that hard because there's only, again, 1,000 times 8, there's like 8,000 ways to try it and you just try them all. Obviously you could short circuit it if they're valid. But let's just think for like one more minute. I'm going to give it like one more minute before I say that. So if I had a function that said this one's unsafe because of we decreased here, we thought we were increasing, but we decreased here. Is that sufficient enough to know that we? Yeah. See, you kind of want to, like this one is actually a really good example of a simplified version that will trick you. I guess is the way to say it is because you say to yourself like, oh, I'm increasing, but I decrease here. Should I just decrease? So I just remove this, and now all of them are increasing. That works. But like I had mentioned before, if the 3 was here and the 1 was here, the answer is still to remove the 3, right? If they're reversed, the answer is still to remove the 3 cuz and then you go increasing. But now how do you determine if this should be increasing or decreasing? You actually have to check the whole array and say is there only one that's out of place from the increasing or decreasing that I think there is? And then you have to do it like the opposite way. So now for the increasing decreasing, you're doing a whole bunch of checks. So I mean, let's just try and brute force it, right? Um, so do we turn this? Let's turn this function. Uh, what is the format button? Why is it not formatting? Alt Shift F. Interesting. Okay, so we have this predicate function, and in the filter, we should now just say if predicate report turn true. Otherwise, something about it VS Code and its formatting is a little weird. If this is not the case, what we're going to do is we're going to try and remove each element and then just try again. What is this? It says it doesn't need to be mutable, but surely it does, because cannot borrow new report as mutable as it behind an at reference. Oh, it's because report is a pointer to a pointer, so I think we just do like, does this work? Yeah. So we dereference it and we clone the dereference, then we remove the ith element, and then we check if it holds true. If we go through all of them and none of them are true, then we flail. Ooh, I didn't copy part 1. So this is actually part 2. Okay, so for part 1, we're doing the same thing. We've just changed the predicate function to right here. So that this predicate function actually has not changed. For part, and so you can see we just literally use, in fact, you just do like that. Type mismatch. Oh, it's because of how report is. Okay. I actually don't know why that's the case, no, now that I think about it. Oh, I bet it's because I've given these types here, like this type, and so this closure will like auto figures it out. Okay. Anyway, part 2. So we're just gonna brute force it. We literally just say if the first one passes, we're good. Otherwise, we're gonna try and remove each one of the items, and then test that one. And if it works, then we it's okay. Otherwise, we return false. Then we do the same thing. We count and do it again. Okay, so let's see. Let's make sure I didn't break this. Okay, I mean, it didn't go up by much, but it did return really fast, and so it feels like, oh, there we go. Okay. Okay, so sometimes brute forcing is okay. Again, this is where you want to check the data. I'm sure I've said this before in my videos, but like small data sets, you can often just brute force it. I mean, I guess what I would ask is, I'm probably going to stop here with my solution. But I would be interested if you did it another way to show me. Did you go through the effort of determining which ones were okay and which ones weren't? Yeah, I think you'd have to just build in some funky, fun logic. I don't know. Maybe you could ask AI which of these numbers doesn't match. Maybe it could figure it out. I doubt it, but um, yeah. The dupes would actually not be bad. You could say, if I find a dupe, can I just remove the dupe and it's still valid, right? Um, the incrementing, decrementing seems kind of hard. It feels like you almost have to try them anyway to get all the corner cases, right? Like, if you feel like if this one's marked unsafe, it feels like you'd almost have to try them all anyway to see if it fixes it. You still have to go through additional logic too, right? Imagine if there's a 1 3 2 4 4 5, right? You can do a single. You can remove a single one from it. So like you might say, "Oh, I can fix this one, but you still have to do the other one." So there's probably some recursion that has to happen there. I don't know. It feels very complicated. So if you came up with one that actually worked and handles all the edge cases, I'd love to see it. That would be interesting to see. Maybe I'm overthinking it and there's a simpler way to do it. I'll go look at the solutions afterwards too. I mean, maybe we can just look right now. Reddit.com. Advent of code. Okay. I do like some of these memes. It is kind of funny. They're just like, why don't we just delete some of them? Uh, where's the solution? Is it not pinned anymore? Oh, here it is. Uh, one line ish Python. Should we look at this really quick? Okay, bro. That looks like it only does part one. Did I misread that? Oh, just part two. Yeah, it does do part two. There's it's doing a removal, right? So here's where it's like grabbing the lines. Here's where it's splitting the lines into numbers and turning them into integers. And then for each of those, zip L1. Yeah, he does kind of like a remove here. So this actually only solves part two, it looks like. But I mean, that is okay. Python pros always get me. I think that you actually see a lot of people doing Python for these solutions because, like, Rust in its typing system can sometimes, make you have to do some stuff. I did a write up. Let's see if they did it any interesting way. Looks like what he's doing is, I mean, this kind of, I'd have to, I'm not grokking what he's doing there for some reason. I'd have to read that a little bit more. Rust, brute force part two. Oh, okay. Well, I mean, we both brute forced it. Anyway, I won't go through all of these. Yeah, he does. He's just doing brute force here, right? So he uses the range to like just pull out, one of the values, but not the first. I guess I don't understand why you don't do this one. Anyway, brute force. Ooh, here's Go. I work a lot in Go. Is Valorant with tolerance? Okay, so he is, I mean, it's still a little bit brute forcey, but much less so. He actually is returning the invalid locations and then trying removing the ones that are invalid. So you do have to do some logic here and say, okay, which one of these are invalid? Oh, it'll say like, oh, I was increasing and then I decreased here, so I got to bail, or I got 2 4s here, so I got to bail. And so he's using that logic to try and fix it. Okay. Anyway, I'd actually be more interested in your solutions, so I'll post mine on Gist, and you'll see it at the bottom of the video. If you have an elegant one that kind of does some checking as opposed to just brute forcing it like I did, love to see it. So that's day 2. We'll be back again for day 3 tomorrow. Um, and yeah, I'll if I find, if you want to share your stuff, I'll be happy to post it in the video so we can like go over it in detail. I'll read it more thoroughly than I did those ones. So thanks everybody. We'll see you later.